Live from YouTube, welcome to the Chicago Python user group. My name is Joe Jasinski, and I will be the MC for tonight. Let's bring us off here. Thank you for joining us. This is our June main meeting. And before we get started, I'd like to just go over our code of conduct. And our code of conduct is basically how we expect people to talk to each other in real life and online. So please review that on our website, ChiPy.org, and please abide by that. So what is ChiPy? ChiPy, or the Chicago Python User Group, is a Python community, or focused community that started in 2003. We started as a small little group meeting in the back of a bar and have grown to be one of the largest Python communities in the world, with hundreds of people on our various channels and many events each month. So ChiPy is put together by a board of directors, but we also have a lot to owe thanks to all of the volunteers and organizers that help make ChiPy possible. We have lots of different events that happen, and without their help, we won't be able to put on as nearly as much as we normally are able to. For example, we have Python Project Night, which is a space where people can meet up and work on different projects together. We have the Buddy Mentorship Program, which is on ChiPyMentor.org. It tries to match mentors with mentees. We also have the Python Lunch Break, which is basically ChiPy meetings, but during lunch for to service the different hours of people watching that. We also have, or this is where you can go to find more information about the ChiPy Mentorship Program. If you go to ChiPyMentor.org, you can learn about the Buddy Mentorship Program. Also, we have a job board. So if you're seeking a job, or if you're looking to post a job, please check out our job board at chipy.org/job-board. Finally, we have a number of different special interest groups. We have a finance SIG, a data SIG, web dev and DevOps SIG, and an algorithm SIG. And they allow us to focus on different aspects of the Python community and different aspects of Python. Speaking of which, we have some of those special interest groups have meetings upcoming. On June 17th, we have the next Python Project Night and Web Guild meeting. July 1st, we have the ChiPy Algorithm SIG meeting. And then our next main meeting is July 8th. So just some Python news. Python 3.10.0b2 is available. So we're starting the countdown to getting to 3.10 release. Really exciting. Lots of new features. What I found was kind of interesting is the Python community is hiring a project manager for focusing on packaging. So it's neat to see someone would be in the mix of trying to manage the Python projects. Also, we had a few big releases of some major Python projects. Flask 2.0 came out, and after about 3 years of 1.0, 2.0 made it out, and Jinja 2 is now Jinja 3. So that's pretty cool, because for years we've been referring to it as Jinja 2, and now it made a 3.0 release. And one of the major things of both Flask and Jinja is they dropped Python 2.7 support. So most of us should be done with that by now anyway, though. So tonight's schedule, we have a great talk planned by Meredith and Meredith Luft, and we have he's going to be talking to us about Anvil. So we can look forward to that in just a few minutes. Also, if you want to participate, if you want to ask questions within the live stream, feel free to go onto YouTube and chat in the sidebar on YouTube. And just note that there's a few second delay between when you say something and when the speaker says something. The stream has a few second delay. Finally, a question for tonight, which you can start responding to in the channel. What Python news have you heard of recently? Let us know if you found anything interesting in the Python world, and feel free to share that. So after tonight's meeting, we're going to hang out in ChiPy.town, which is basically a 2D little interactive space where we can hang out and kind of meet in a little live stream environment. Please note that it's HTTP ChiPy.town. It redirects to HTTPS gather town. But if you go to ChiPy.town after the meeting, feel free to come and hang out. If you could find us on our Slack, we have a pretty active Slack channel. So go to join ChiPy Slack at herokuapp.com to join us if you're not already part of it. Also, if you want to follow us on Twitter, our handle is @ChicagoPython. And finally, if you don't remember anything from this talk, all of the resources I just mentioned are available and reachable through chippy.org, our main website. So check that out. Finally, our sponsor, JFrog, has a monthly raffle with ChiPy, and this month we have a CircuitPython compatible Adafruit kitten bot this month. You can scan the QR code or click on the link that I'll drop in the chat, and the winner will be selected in the next few days, and it will be shared up on our meetup page and congratulated on social media. With that, I would like to move on with our first speaker, and I'd like to bring our speaker onto the stream.
Hello, hi, great to be here.
Hello, thank you for joining us. Why don't you tell us a little bit about yourself?
Okay, so my name is Meredith. I am currently joining you from Cambridge, the one in the UK, not the one in Boston. So it is currently midnight story hour. We'll see how well I do with the wakefulness. I am one of the original creators of the Anvil web framework, which is what I will be here talking about. In the rest of my time, I stay inside and stare at blinking boxes, talking to people who aren't there, same as everybody else for the last 18 months or so.
Cool. So how did you first get into Python? What got you started?
So I first encountered Python. I can't even remember when it first was. I think it was at university. We got seriously into it when we used it as the basis for Anvil. So my background is sort of in programming language, programming systems. So I've been vaguely aware of it. I just hadn't used it properly in anger until around 2014 or so.
And so besides Python, do you have any other languages you dabble in, or what's your favorite?
I'm a bit of a Lisp nerd, so I spend a lot of my time writing closure code. The one I'd really like to try is Rust, which I haven't got round to yet, and then like the low-level system stuff, C++. But like, if you ask me for favorite that wasn't Python, Lisp would probably be up there.
Yeah, Lisp, I did that at school, and that was a fun language. And Rust for sure.
It's one of those ones that like gives you the right kind of like enlightenment moment when you get your head around it, and also leaves you the right kind of headaches.
Well, enough of my talking. I'd like to turn it over to you, and we could start with your talk. Take it away.
Awesome. Thank you very much.
Let me jump off the stream here.
All right. So, hello. I'm Meredith. You know a tiny bit about me already. I am here to talk about a framework called Anvil for building full stack web apps entirely in Python. So that is Python running in the web browser, Python running on the server, even a Python UI toolkit. And the first question, quite reasonably, about something like this is going to be why? And to answer that question, we need to talk about the web, and specifically what it's like to use the web as a programming platform. So let's look at the web from the perspective of your data. So if you're building an application, your data is probably going to start as rows in a database table, accessed by SQL in a typical application. But of course, it's not going to stay there. You are immediately going to transform that data into Python objects running on the server, accessed by methods and attributes. And then you're going to turn around and represent it as JSON over HTTP endpoints with this weirdly limited set of verbs: get, post, put, delete. And then you're going to, at the other end of that HTTP is, of course, a JavaScript program that is reassembling those payloads into JavaScript objects with their own methods and their own attributes, and then rendering those into HTML DOM, which is an API all of its own, and using CSS to style those into pixels. And that is a lot of different representations of your data. And indeed, the day-to-day work of web programming is mostly converting your data or translating it between these different representations. Now, this is tedious and repetitive, and so we invent automation, and that automation ends up being a rather dangerous sort of magic. So let's look at an example, which is SQLAlchemy, which is slightly an unfair potshot because this is a really cool library. If you're not familiar with it, it automates the translation between rows in an SQL database and Python objects. So where in SQL you would write an expression like this, in Python you can write an expression like this, just in Python. So query book filter book.price is less than 20. That's nice. But of course, the process that turns that Python expression into SQL you can execute against a database is black magic.
One second here. It seems like we've had a little bit of technical difficulties. We'll be right back with Meredith in just a few minutes. And in the meantime, if you'd like to sign up for the raffle, I'm going to put that slide up on the page. But let's see here. There we go.
Hello. Can people hear me? Yes? You're muted, Joe, but I'm guessing that's a nod from you. Awesome. I apologize for that. It appears that the fiber-seeking backhoes are out in force in Cambridge, and somebody decided that 20 past midnight on a Friday was a good time to cut off residential internet access. So I am back through the magic of 4G, and let us get back to the pleasures and dangers of the web. So if you can full screen me, please, Joe. All right. So just to recap, we've been talking about the web. We've been talking about the web stack. So that is all the different representations your data goes through when it's going from your database to your eyeballs. And we've talked about how the day-to-day work of web development is mostly translating data between these representations, which is tedious and repetitive. And so we get automation to help us do it. But that automation comes with its own problems. And to illustrate this, let's take a look at SQLAlchemy, which is a library for automating the translation between database rows and Python objects. So instead of writing an SQL expression like this, you can write a Python expression like this. But the process that translates that Python expression into SQL you can run against a database is black magic. We are talking metaclasses. We're talking overloading an innocent Python operator to do something it never expected. And if you poke this, you will burn yourself or at least you will need to know how it works. Because if you try to treat book.price is less than 20 as if it were an ordinary numerical comparison, you're going to come unstuck. And you're going to have to learn that it is, in fact, an overloaded operator that's returning some strange intermediate value that's going to be used to generate source code in a different programming language. Which means that to use this system effectively, you're going to need to know Python and SQL and how SQLAlchemy does the transformation. Now, in exchange for all this extra complexity, you get to write your programs more quickly and efficiently. But the cost is more complexity. You might get away with it if you do this once. But if you did have magic like this at every layer of this stack, you were in for a bad day. And that is, of course, exactly what we do. We have ORMs like SQLAlchemy helping us translate between database tables and objects. We have REST frameworks helping us expose those objects as JSON. We've got JavaScript frameworks like Angular's resources helping us reassemble that data. We've got templating engines like React helping us to produce HTML DOM. We've got CSS frameworks like Bootstrap helping us represent it as pixels. And all of those are the kind of magic we just saw, where you need to it's abusing the semantics of one layer to represent another, which means you need to understand both representations it's translating between and how the framework works in order to get anything done. Well, we're Pythonistas here. How does that stack up against the Zen of Python? Simple is better than complex? I mean, that was not a simple system. So many moving parts. Here's another famous one. If the implementation is hard to explain, it's a bad idea. Well, the insides of JavaScript frameworks are famously gnarly because they are doing this kind of twisting one thing to represent another trick. Here's a really famous one. There should be one and preferably only one obvious way to do it. Do I need to say anything else here? It's just a mess. So looking at this, especially if you have a background in programming usability, you're inclined to ask, how could we do something better? And looking at this stack, it's pretty clear that just making another web framework isn't going to help you. Because if you just swap out one of these orange boxes for a better orange box, you haven't solved the big problem, which is that you still need to understand all of these different languages and all of these different frameworks, and you just added another framework to learn. So we thought, okay, if we want to make progress, let's replace all these different representations with one coherent representation. And for that, we've chosen the Python programming language. So we've built a user interface toolkit that's Python-based, a system for running Python in the web browser. So now, instead of driving your user interface by generating code in one programming language and then styling it with a separate programming language, HTML and CSS, instead of that, you can just manipulate Python objects. Python on the server, of course, but now we've got Python on the client and Python on the server. We don't need to mash all of our data into JSON anymore. We can just make a function call. We even built a Python native database where the semantics are Python objects rather than relational rows, which means that you can pass your data all the way from the database to the user interface without changing its representation. It's always a Python object. And that lets you build things much more easily. All right, that's the idea in theory. Let's see how that looks in practice. If you'll excuse me while I configure my workspace. All right. So what you are looking at here, what I'm looking at here is the broadcast window. There we go. What I'm looking at here is the Anvil editor. And I'm going to show you how this framework works in practice by building a web application. So here I am in the editor. This here is a web page. And this is a toolbox of things I can put onto that web page. So for example, if I want to put a title on my page, I drag a label here, drop it in the title bar, and then I can set its text property to Hello ChiPy. All right, let's be a little bit more interactive. So I'm going to build an application that prompts you for your name and then greets you by name. Simple hello world thing. So we'll have a card. We'll have a label on that card that prompts the user to enter their name. We're going to have a text box so they can answer that question. Let's zoom in a little bit, shall we? There we go. I'm going to call this name box. Every component in Anvil has a variable name so we can access it from code. I'm going to put a button here for them to click when they're done. And you can see what's going to happen here. They're going to enter their name, go to click a button, and a message is going to appear to greet them by name. So the final thing I need here is a label to display that message. I'm going to call it message label. And I can go in and edit the text properties, and I can make it centered, and I can make the font big, and so on. So I've just built a web page. And obviously that was a lot faster than it would have been with HTML and CSS. But the really cool thing is that this is all backed by Python. So if I double click this button, I'm editing the Python code that runs when this button gets clicked. And you can see all the things I've dragged and dropped onto the page are available as variables in my Python code. So if I want to set the text on this message label, I just go self.messagelabel.text equals hello self.namebox.text. And that was it. So if I run this application now, oh, did I mess up my, I did mess up my UI. I'm not quite sure how I did that. Yeah. All right. So that we've just built an interactive application with nothing but Python. It's actually already live on the web. Let's give it a better URL. Okay, so you could apply that. You could go to hello-chipy.anvil.app right now, and this application is live. So please, as you're following along, do feel free to trust but verify that I am in fact building this thing live. Okay, so this is all very neat, but everything I've been doing so far is running in the browser. Even this Python code gets compiled to JavaScript and runs in the browser. We'll show you how that works in a moment. But any serious application is going to need some server-side code too. So let's add a server module. So this is a Python module that runs on the server. This is a perfectly ordinary Python module. This is a perfectly ordinary Python function. But what I can do is I can tag this function anvil.server.callable. And that means that this function on the server can be called from the web browser. So let's go back to the browser code. And as well as updating the UI, when the button gets clicked, we want to call this function. We want to call the say hello server function. It wants a name parameter, so we're going to give it the text from the name box. And now when I run this code, you can see I've got some output in the logs. And that's a print statement running on the server being driven by this UI we've built with nothing but Python. And now we're really in business, because obviously there's limits to what you can do here. Everything's being compiled and run in the browser. You're not going to be able to access the file system. You're not going to be able to do an enormous amount of number crunching. But here we are on the server. This is a proper CPython instance. You want to connect to a database, import CycloPG2, go. You want to do some numerical computation, import NumPy. You want to do some machine learning, import TensorFlow. It's just Python. In practice, the first thing everybody asks is, how do I set up a database? So we have a built-in database, data tables, and this is backed by Postgres, so you can happily stick gigabytes and gigabytes into this thing. I'm going to be a little bit less ambitious. I'm just going to record all the names that get entered. So I'm going to want a text column for the name, and I'm going to want a date and time column for when that name was entered. And that's it. I have constructed my database. This table is apptables.visitors, and we can access it from our code in exactly the same way as we could access those buttons and labels and so on. So on the server, when they click the button, as well as printing something into the logs, I can record into apptables.visitors. I can add a row. I fill out the name column with the name that's been passed in. I'll fill out the when column with datetime.now, which I need to import. And now, when I enter a couple of names here, and if I go look at the data tables, I can see that I've actually recorded that data in a database. So I just built and deployed a database-backed web application in nothing but Python in a very short period of time, even with that internet interruption. OK, I'm going to show you one more thing before we go behind the scenes and I show you a little bit about how this works. I'm going to show you how we can display this data back on the screen. So the first thing we need to do, of course, is to have some way of getting that data. So we're going to have to write a server function that gets the visitors. And then we can just return @tables.visitors as search. So this will return a lazy search iterator. If we don't specify anything, it'll just return all the rows in the database. And now we go back to the browser and give ourselves a way of displaying it. So I'm going to put another card on here. I'm going to add a data grid to that card. And there's going to be a column for the name, which is going to pull the name key out of everything, each item, and then a column for when, which is going to pull the when key out of this item. And the third column we don't need at all. And this when column we can shrink down a little bit. OK. So inside this data grid is a component called a repeating panel. And this has a property called items, and you can set that to any iterable Python object, and it will iterate through that object, and it will instantiate this chunk of user interface for every item in that iterator. So all we need to do when this page loads, we set the items of this repeating panel to be the return value of that getVisitors function. So now if we run this, we're displaying the data from the database, and we can see we've already had some people submitting. Hooray. One more thing, this when column is looking a little bit ugly. You can see what it's done. It's just got a date time and it's called stir on it because that's the default behavior for just display me this piece of data. So let's go in and format that a little bit more nicely. So I'm going to go in and edit this template. And instead of the default behavior, I'm going to put a label in this column. And I'm going to add a data binding. so that the text of this label is set to this Python expression. And so I'm going to use self.item, which is a row from the visitors table. This is a Python, the object that we got out of the iterator, which was passed back from the server. And I can pull out the when column, which is a datetime object, which means, of course, I can just call stir of timeout. All right. So now if I run this, we've got these dates more nicely formatted. So that was a whistle-stop tour of what Anvil can do and how to use it. Now it's time to take a little bit of a look behind the scenes and see how it's done. If you will excuse me, I now need to... all right. Return to the presentation. We're going to talk behind the scenes. Untie myself from my office chair first. Okay. So, the first thing I should say is that the framework I'm presenting is, of course, open source. So you can go onto GitHub, and if you want to investigate anything that beyond what I have time to talk about today, then feel free to go rummage through and explore, or you can pip install the local version yourself. So let's talk about a few of the things that I've just shown you. I'm going to start with compiling Python to JavaScript, because obviously that's a pretty big deal. If you're going to be doing full stack entirely in Python, then you're going to have to make code that runs in the browser, and the browser only understands JavaScript. So if we're writing Python, we're going to have to translate it. We use a Python to JavaScript compiler called Sculpt. So how Sculpt works is you give it a string of Python source code, and it will produce a string of JavaScript source code that does the same thing. If you give it a Python function, it will produce, honestly, the ugliest JavaScript function you have ever seen, but it will have the same semantics as the Python it took. Now, I'd like to tell you a little bit about the first major change I made to Sculpt, which was important in providing some of the APIs you saw me using there, because idiomatically, a lot of Python APIs are blocking. We have optional async these days, but your average code, and certainly the code you'll show to a beginner, is blocking code. Now, JavaScript, in its infinite wisdom, is a 100% non-blocking language. So every function must return immediately so that the browser can continue doing anything at all. So this is the sort of code that we'd be expecting to see in Python. So, fetch something from a database, do some computation on it. Here's the sort of thing you'd need to write in JavaScript. So you've got a bunch of nested callback functions, each of them executing at an individual point along the way, and you can't just block waiting for some data. Now, if you're used to JavaScript, you might say this is that's an unfair representation of how to access a database in JavaScript. I would say that was actually copied and pasted from the first page of the Postgres JavaScript API documentation not that long ago. You might say, fine, but that's still outdated. These days we use promises and async await, and you would be right, but promises and async await are another example of an abstraction like SQLAlchemy. They speed you up, but to use it in any depth, you're going to need to understand that it's all really callbacks under the hood. But wait, we have a Python to JavaScript compiler. What if we could transform this into this automatically? So we check out the source code and take a look. Turns out that Sculpt has a classic compiler architecture, unsurprisingly based on CPython. So if you feed it some Python source code like this, the first thing it will do is it will tokenize it by the way that .js files, the files in the Sculpt source tree, tokenize it, so split it up into a set of small strings with meaning in Python's grammar. It will then parse these tokens and assemble something called an abstract syntax tree, which is a tree representation of that code. So here it is. We have an assignment. On the left-hand side is a variable named result, and the value being assigned is the result of a function calling a function named f with a argument which is a numerical constant 42. So we've now got a sort of Python-shaped representation of this code, and there is a compiler that walks over this tree spitting out JavaScript. So if we want to automatically transform blocking Python into non-blocking JavaScript, clearly this is where we're going to have to do it. And what we did was we invented a new sort of return value. Because remember, every Python function becomes a JavaScript function. Every JavaScript function has to return. So we invented a new return type that this function could return to say, I'm returning because I have to, but I'm not finished, I've just blocked. And we call this a suspension. So when we are compiling a function call like this, we compile it into code a little bit like this. So we do the function call, and then we check, is the return value a suspension? And if it is, then this currently executing Python code, needs to suspend ourselves. Here's how that looks in practice. So here we've got a function triggered on a button click that's going to go and hit a database and then do some computation on it. So at the point where we hit the database, we've got the Anvil runtime is handling the button event. It's calling button one click, which is called that get method, which has hit the database, and the database has blocked, which is to say it's returned a suspension. Now the get function, the get method, will realize it's been given a suspension rather than a return value, so it will suspend itself. It will save its local variables, it will save its temporaries, it will save where it is within that function, and then it will return all of that as another suspension object with a reference to the original one. Button one click will do the same thing. It will save its locals, save its temporaries, save where it was in the function, and return a suspension back to the Anvil runtime. And the JavaScript at that point can just sit on it and return control to the browser. But a few milliseconds later, when the database gets back to us, we can resume that suspension. And that's a special way of calling the button one click function, but not calling it from scratch, saying actually just here's a suspension, so to restore your state and resume from where you were. And so the button one click will then restore its local variables, restore its temporary values, jump to the right place in the function, and then resume the nested suspension, which will restore its locals, restore its temporaries, jump to the right place in the function, and resume the inner suspension, which now returns immediately because the database has got data. And at this point, we are back to executing normally. We've reinflated our stack, and we can carry on. And that's how how I modified Sculpt to transform blocking Python into non-blocking JavaScript. If you're interested in learning more, check us out at sculpt.org. I'm one of the maintainers now, and we're always looking for more contributors. Please do come join in. All right. So that was Python to JavaScript. Let's talk about something else that's really crucial to doing full stack in Python, which is the way that we could just do those function calls between browser code and server code and pass around things like database iterators. So we support this thing, anvil.server.call, which does, it's a Python function call. It's got, you name the function you're calling, and then you've got positional arguments, you've got keyword arguments, you've got return values. And this is implemented by doing a remote procedure call over WebSockets, and the argument and return data are encoded as JSON, which is fine for the sort of data you're seeing there. But what about the non-JSONic data? Like, for example, those lazy database iterators and database rows you saw me casually passing around just now. So for this, we have something called portable classes. So you can take a class in code, in a module that can be loaded by both client and server code, and you can decorate it as anvil.server.portable class. And that means that when the RPC mechanism sees you passing one of these things into or out of a server function, it will serialize it as JSON. So it will take the contents of your class, by default the dunder-dict, so the instance variables on this class, and transmit those over and then reconstitute the class, the object at the other end. If you want more control over how it goes over the wire, that's fine. You can implement the dunder serialize or dunder deserialize functions, and those can return or take anything that the serializer knows how to deal with, including other portable classes. So you can do some very clever things here. You can implement, for example, whole database systems. And so that's how we can take things like a database row object and return it through server code to client code and interact directly with bits of our database from the client, which is obviously a very powerful thing to do. Because we have this object, it's live, we can call methods on it. In this case, we're calling a dunder get item method, which is implied by those square brackets, but we can do a lot of other things as well. But we are missing one thing, which is security. Because when you call a method on some database object in the client, and it doesn't have any kind of cache data, it's going to have to make a call back to the server to do whatever it is you've asked. And just because, in this case, we've given the client code access to some database objects, doesn't mean that our untrusted client code, which is, remember, that's controlled by the person in the web browser, possibly malicious visitor, we don't want to give that access to all database objects. So we need some sort of permission system. But a permission system that preserves this nice property that you can just throw these objects around, return them from functions. And what we built was a capability model. So a capability is, formally in computer science, it's a non-forgeable object that grants certain permissions by holding it. More colloquially, if you've got it, you can use it. So the model we're going for is that if the server code, which is trusted, returns some object from the database to the client code, then the client code can do things with it. But if the server did not choose to return that object to the client code has no access. The way this is implemented is to take some sort of identity and some permissions and sign those with a key that is known only to the server. And so when the client makes a request, it will pass back the capability with that call. And the server can check. And if there is a valid signature on that capability, then the server must have given the client access to that particular object so it can choose to proceed or not with what the client's asked for. So here's an example of constructing one of those capabilities. So here's a capability that's scoped to database and a particular table ID 42, row ID 12, access read only. And if we get a valid one of those coming in from the client, we know we must have given it to the client at some point. And this is what enables us to do things like returning objects. So here's some server code that's returning a row from the database, but it's checking whether there's a user logged in, and only if there's a valid user login is it going to return that data. So the if statement that controls whether you give them the data is exactly the same thing as what's controlling whether you give them permissions, which means that you don't end up with these situations where those two things get out of sync and you have security issues. And then, of course, on the client, it's really easy to use. You can just get the return value of a function and do things. You can be more clever than that. You can set some permissions. So here we're returning a client. We are returning a client writable version of the row. So we take the people view, we get the client writable version of it, and then we search that. And that means that the capability that goes back will say it's client writable. And now we can update that database row from our client code. So we can update the database from the event handlers of our user interface, which again means that we no longer need to plumb every action in our application all the way up and down the stack, which is really going to speed you up. We can be even more advanced than that. we can return views on tables. So let's imagine we have a table like this. So we have a set of records and they are owned by some user. So that's linked to another table. And what we want to do is to give the client code access to this table, all operations on this table, but only the rows where this currently logged in user owns the record. And we can do that by returning a client writable view. So this is code that checks whether the user is logged in, and then it returns apptables.records.client-writable, a client-writable view, but only where owner equals this user. And what that gives the client is an object that acts like a database table. So you can query it, you can add rows, you can delete things, but you can only ever access rows that meet that constraint. And so you can offload an enormous amount of the logic of your application all the way to the client-side code, so you only have to write it once. So we've talked about compiling Python to JavaScript. We've talked about how the function calls work. We've talked about how capabilities make passing these live objects around secure. I want to finish by talking a little bit about the development environment you saw me using, and specifically the autocompletion. Now, autocompletion is very important if you're building a development environment like we did, paired with the framework. It's important because it gives you discoverability. You can just find out what's in an API from the autocompleter without having to go browse through reference documentation. It gives you speed because you can just hit the tab key every few seconds. It gives you confidence that what you're doing is right, because there are whole classes of bugs you can find and fix without ever hitting the run button, because the autocompleter gave you a hint that you weren't actually working with the value you thought you were. And for all these reasons, it just feels good to use. Now, if you're already a die-hard PyCharm or VS Code user, you didn't need me telling you this, you knew how wonderful autocomplete was. If you are a Vim or Emacs partisan, that's okay. There are, in fact, off-the-shelf autocompleters like Jedi that you can get and you can get plugins to integrate something like Jedi with Vim or Emacs or what have you. And if you use something without an autocompleter, I just do me one thing, remember nothing else from this conversation, just try an autocompleter for a week, you'll be amazed. Unfortunately for us, an off-the-shelf autocompleter like this wasn't quite enough. For one thing, Anvil's full stack, so the autocompleter needs to know about your database schema, about your server code, about your client code, even about your user interface design. Now, that's fine. That means we couldn't use it off the shelf. We could have hacked that functionality on. But the other thing about Anvil, and the development environment in particular, is that it's web-based. And something like Jedi is expecting a file system. And when you hit the tab key, there is just not enough time to go all the way to the server, parse all that Python, get the completion values back to the client, and display them. If you've ever used REPL.it, it's a really great playground for using lots of different programming languages. But its Python autocompletion is definitely done like that, and you can tell, just like it's a couple of 100 milliseconds between hitting the tab key and getting autocompletion. It completely throws me off my game. So we wanted to be a little bit smoother than that. So we had to build an autocompleter ourselves in JavaScript, which would seem like a pretty tall order, except, of course, we already have a Python to JavaScript compiler knocking around, and we've already seen how we can use it as a parser. So what we do is when you hit the tab key in the Anvil editor, we replace your cursor with a special symbol, and then we feed that module to the sculpt parser, and we get an abstract syntax tree. And then we can walk over that AST and deduce things about, for example, what variables are in scope at any given moment. So we walk over a def function. Oh, well, that's got arguments called self and event args. Those variables are in scope now. we've got an assignment to a variable called x. Well, okay, x is now around and it's a string. And the call, oh, here we are, we've run over the cursor symbol. But we know what's in scope now, and so we can offer those as our auto-completion options. Obviously, you can do this with an awful lot more than just which variables are in scope. So here we are doing something you saw me doing earlier, which is auto-completing columns available in a database row. And actually, the autocomplete has done a lot of inference here, because to get to this autocompletion, it's got to work out what happens if you take the app tables module and get the users attribute from it, and then what happens if you get the search attribute from that, and then what happens if you call that as a function, what you get as a return value, and then what you get if you iterate over that type of object, and then what you get if you do an item, what options are available if you do an item lookup on that object. But that's okay. If you just walk through the AST, you can sort of recursively work out what type all these expressions are and keep a sort of running score. We can also do a bunch of full stack autocompletion. You've seen this is kind of full stack. It's accessing the database, but we also want to do it between server and client code. So if you do a function call like this, amble.server.call say hello with passing an argument in. Now, in a normal web development environment, you would have no clue how to autocomplete this, because you'd be going and often talking to a different program written in a different programming language with heaven knows what framework, and it was basically churning hard to work out what's being passed in or out of those functions. But because everything is Python here, this is actually fairly straightforward. When the autocompleter is walking over code like this, it realizes that it is calling a server function called say hello, and it notes down the types of the arguments. And then when we are parsing the server function for autocomplete, we can go, aha, I am parsing a server function called say hello. I know what arguments this gets called with, and so we can stick those arguments types into the local scope and they autocomplete. And that's how we can do full stack autocomplete. We can autocomplete really quite a lot about an object, which leads to a rather philosophical conversation about what exactly a type is. You could say that the type of an object is its Python class, but Python's a very dynamic language. You can add extra attributes to individual instances of an object, and sometimes you might want to treat different instances of the same class differently. So what we do is we say, actually, we sort of half forget the formal type, we duck type our autocompleter. So as far as the autocompleter is concerned, these two variables have two different types. Obviously, they have a lot in common, but they are tracked separately so that when you autocomplete, Douglas Adams here, it knows and can help you choose which item lookups are available. So that's a little bit of a tour through the Amble autocompleter. We've talked about the web as a platform, its pros and cons. We've talked about the architecture that we've built of a full stack Python web framework to try and do something about it. You've seen me using it, and we've talked a little bit about how it was built behind the scenes. I would like to finish up by talking a little bit about the why, the design philosophy behind everything you just saw. And there are two big principles here. The first is that code is good. It is the best way to tell a computer what to do. We have been telling computers what to do for about 3/4 of a century by now, and in all of that time, nobody has come up with something better than this pseudo-algebraic thing of writing text in a programming language. From time to time, people come along and say, oh, but writing this code is all terribly difficult. Let's build something where you can build your applications with no code. And this is a false promise. Because if you use a system like that, you're going to hit a brick wall when you try to do something the creators didn't envisage. Well, either that, or you're going to be dealing with Cthulhu's own flowchart in whatever drag-drop system they've got going, and really tying yourselves in knots and a whole bunch of computational thinking for something that could and should be a 5-line for loop. What's the answer? Don't try and do it all with flowcharts. The problem with web development is not the development, it's the web. So get me to the code. Let me write that 5-line for loop. Even in the user interface designer, you saw when I wanted to, when I was connecting the, we're formatting that date for when that name got entered. I wasn't dragging and dropping some kind of noodle visually from the database onto the page. No, I wrote a Python expression. And because I was writing a Python expression, when I needed to format a date, I could just reach for the standard library and use all the powers of the datetime class. Code is good. Get me to the code. Big principle number 2 is about accessibility. Now, if I were to go in a few months to an in-person meetup and ask some people, what would it mean for a web framework to be accessible? You'd probably hear something like, well, that it's about being easy for novices to pick up and use. And they're not wrong. It's frankly a little bit embarrassing that the greatest application delivery platform on the web, in the world, that is the web, requires you to know all these different programming languages and all these different frameworks just to get started. It should be simple enough for novices to build something. But that's not enough on its own. It's not enough for the novices, because if you put them in a playpen and give them only kitties' toys, they don't have room to grow their powers. And today's novice is tomorrow's intermediate programmer, is next year's expert. So you're doing them a disservice. But it's also not enough for the professionals, because they're the people who are actually experiencing arguably most of the pain of the architecture of the web as a development platform. Just because I can write 5 different programming languages and 5 or 6 different frameworks doesn't mean I want to do that just to get out of bed in the morning. And it doesn't mean that anybody in my company or any of my customers want to wait for it. So if you want to be properly accessible, you can't just be simple enough for novices. You've also got to be powerful enough for the pros. And you might be looking at that pair of criteria and thinking, yes, Meredith, that's all very well in theory. But in the real world, you can't be both of those things. And I would tell you to look at your text editor. What programming language are you writing? We are here because we speak Python. And Python is, yes, the first language you show to an 8-year-old with their first Raspberry Pi. But it's also the language that powers Instagram, the language that powers whatever the latest ridiculous thing Google DeepMind got up to. It is possible to be simple enough for novices and powerful enough for seasoned professionals. The language we use reminds us of it every day. And it is only the garbage fire of the modern web ecosystem that ever lets us forget. Thank you very much. All right, there's going to be about a 10 or 15 second delay here while we reconfigure all of the broadcast stuff, and we wait for the questions to come in.
Yeah, thank you very much. That was an excellent talk. Yeah, if anyone wants to ask some questions, feel free to do so in the chat. But I have a few to kind of get started.
Please
I
do.
guess the one you mentioned about you're able to serialize the Python objects. Like, are you able to do that for unserializable? Like, how do you accommodate unserializable things like dates, for example?
So to be clear, this is not using an off-the-shelf Python serialization mechanism like Pickle, because Pickle is very it's specific to the particular point version of the interpreter you're using. this is precisely why you have to tag which classes you want to be serializable with Anvil.server.portable type, because yes, absolutely, you can't just blindly try to copy everything and hope things will come out well. But obviously, dates and times are things that you want to be able to pass around between server and client, so we do have special handling for them, and we do handle the time zone difference. So if you put like a time zone naive date time down an RPC call from the web browser, it will arrive at the other end, sort of stamped with the time zone in which your browser was working, to avoid obvious date time maths calamities. But yes, there's a defined set of serializable things. It's in the Anvil docs. You can see what are the types that are supported out of the box. Anything else you have to tag as a portable class. And if there's anything more complicated than just serialize your class's membership dict, then you have to define your own serialization functions.
And we've got a question here from Aaron. Why not use? Yeah.
Okay, so two answers to that question. One is because there are two sorts of question I think you might be asking. One is, why not just ship an entire CPython interpreter as WebAssembly? Because we can now compile CPython to WebAssembly, and then you could run the full fat thing in the web browser. And actually, there's a project called Pyodide from Mozilla that does exactly that. And it's really great. They bundle the CPython interpreter and a whole bunch of like common data science libraries like NumPy, SciPy in Matplotlib. And you've got something like a Jupyter notebook, but it's running entirely in your browser. It's wild. But it also takes a best part of 30 seconds to download and start up, because the CPython interpreter is fairly chunky. So that version of the WebAssembly stuff is perfectly fine for what they're using it for, not okay for something that you want to use for interactive web applications. Other question, why is WebAssembly not a Sculpt compilation target? I mean, a boring answer is that Sculpt started before WebAssembly was broadly supported, and even now, IE 10 is in our support set. More practically, that's the answer for Sculpt, but why is Anvil not modifying Sculpt, contributing that work back to do everything in WebAssembly? And I mean, it's possible, maybe we will go that way. But for Anvil's purposes, we use the client-side code to drive user interface stuff, which actually means that most of the time it's only a couple of steps removed from manipulating JavaScript APIs to begin with. And so having to drag everything over a WebAssembly to JavaScript bridge and back to get anything done is actually not, is not going to be particularly useful for us. So it's not going to be the big win that would justify changing the entire compiler to be generating WebAssembly rather than JavaScript.
We have another question from Jordan. How large is your development team?
Development team. That is an excellent. That is an excellent question. The answer is currently 4. But if you go to anvil.work/jobs, we are recruiting. Although I have to say, if you're based in Chicago, it's going to be a little bit tricky to be in the office with us. So that's mostly for anybody who's joining us from the UK. Yes, 4 of us and growing is the answer.
Wow, that seems like you've done a lot with 4 people.
It was quite. Yes, this is what happens if you get really passionate about a project. It's sort of. I think I mentioned before, my PhD is in building usable programming systems. My longtime friend Ian's is in human-computer interaction, and like the two of us had a lot of pent-up stuff to get out, and we just sort of built it all as fast as we could.
So you have another question here. Let's see.
Can display get live updates like you could with Django channels? This is live publicly on the internet. We don't generally pre-announce things. Not quite yet. Stay tuned. But yes, the WebSocket, the WebSocket is set up to allow that. I don't think it's a secret that it will be on our roadmap to be able to transmit updates.
So regarding Sculpt, what do you see like kind of as a future use of Sculpt? Like, what do you see the direction of it kind of evolving to?
Well, so there's two different questions in there. One is what uses, and obviously that's presumably got to be uses outside Anvil. So the answer is that's already used for a bunch of stuff. If you've ever played a game called Code Sculptor, which is a game where you have to like program your way around challenges in Python, that uses Sculpt. There's a whole bunch of like interactive learning tools and online textbooks that use Sculpt. If you ever use Trinket, which is like an embedding, like Python learning environment embedded in your browser, that also uses Sculpt. There's a gallery of projects on sculpt.org. So like what uses? Mostly education, it seems. We are the only web framework that embeds it. I mean, this is a separate rant. I won't go too deep into unprompted, but there have been a few attempts to replace JavaScript with Python, which haven't really gone very far. And I think a lot of that is because it needs to be coupled with a web framework. Otherwise, you're just swapping one of those blue or orange boxes for another equivalent one. So I think it would have to be another whole web framework to pick up something like Sculpt and use it for what Anvil's using it for. Most of the rest of its use is probably going to be embedded scripting inside web applications or for learning stuff.
So can you mix Anvil with other web frameworks like go
on. You were about to name something?
Like Django or Flask or Fast API.
The answer is absolutely yes. I'm sorry, there's only so much you can fit into a 40-minute talk, but we know how crazy what we're trying to do is. We are trying to build an abstraction over the entire web. And what that means is, I mean, it's a huge surface area. We know we are not going to cover all of it with a nice Pythonic API. So we have built-in escape hatches basically everywhere. And one of them is, okay, if I only want to build my front end, but I want my back end to be a Flask app, that's, of course, you can do that. You can make HTTP requests and use that as your backend JSON store. At that point, you're not going to be getting the benefit of all the calling and the autocomplete, but you can absolutely do it, and you've still got the benefit of the integrated front end. There's a sort of equivalent on the server if you don't want to maybe use write your own backend server, but you do need to use your own, as in physical computer somewhere. Maybe you need access to a particular database that's only it's in a particular physical place on a particular network or particular hardware. So driving something off a Raspberry Pi. There's also something called the uplink, which is a library you can pip install anywhere, and you can get a token from your application and put it into this library running on any Python interpreter, which will then make a WebSocket connection up to Anvil, and your Python interpreter there will effectively join your application and become part of it. So you'll be able to, for example, declare an anvil.server.callable function on your Raspberry Pi, and then call it to trigger some hardware action. We've got some examples of that on the website. So, or likewise, you could run a script somewhere in a Jupyter notebook that extracts and looks over some data from your database. So there's a lot of ways you can be plugging in bits of your own backend infrastructure. And there are, in fact, several places you can plug in your own backend infrastructure there. Using a Flask app is just one of them.
So we have another question here.
What is the biggest challenge developers encounter when trying to use Anvil for general web development? So there are a few possible answers to this question. This is one of those "what's your greatest weakness" questions. I would say if you're coming from a web background, people tend to reach for the JavaScript solution very quickly and tie themselves in knots with JavaScript and DOM nodes, when in fact there is a 2-line Python answer that's a couple of inches away. I would say, so if it's So if your background is in the web, then you're going to sort of it takes you a while to go, oh, actually, I don't need to do a bunch of that stuff that I was doing. If your background is as a very beginner, then the hardest thing is probably that you're going to have to wrap your head around classes a little bit, fairly early on in your journey, just because the user interface toolkit is object oriented. And likewise, you're going to have to wrap your head around the client server computation. I think general web development is such a general thing. I could sort of carry on listing things, and I'm not sure I would answer you with any more satisfaction than that.
And let's see, I have a question too. It's like, what,
Sure.
Like if you want to host your own, like the runtime is open source, correct?
Yes.
If you want to host your own like application running on Anvil, like what components are available to you with the open source option versus the hosted option, or
everything. It's the hosted thing is a hosted version of that runtime. I mean, not quite. There are some hooks in there so that we can manage the multi-tenancy, but you've got the full shebang.
So like the database and such? Like,
yeah, absolutely. So when you pip install Anvil App Server, what you actually get is it's a Python shim that downloads the central API server. It also, when you run it, it will download an embedded Postgres installation and an embedded traffic reverse proxy. So when you if you've built something in the Anvil editor and you want to run it on your own machine, there are 3 steps. Step 1 is the git clone command to clone the app out of Anvil. Every Anvil app is a Git repository, so you can just clone it onto your machine and you get the files. Step 2, pip install Anvil App Server. Step 3, Anvil App Server --app dot. And the server will come up. It will have a database that will be initialized with the data tables that your app is expecting. Actually, if you didn't specify an HTTPS origin, it won't have the reverse proxy. But if you specify an HTTPS origin, --origin HTTPS myserver.com, it will bring up a reverse proxy. It will grab a certificate from Let's Encrypt, and you will be live on the internet. We've tried, Anvil is an abstraction over many of the problems with the web. I didn't really get into the DevOps problems with the web, but they are quite severe. Again, like the entry level, you must be this tall to ride this ride, for web development also involves setting up servers and keeping them up to date and a whole bunch of challenges. And obviously, our hosted service is about taking that away completely, those problems. But if you want to run it yourself, we've tried to replicate as much of that ease of use as we possibly can. And so we have all these things out of the box. Now, obviously, if you want to bring your own database, you can just give it a connection string and it'll connect to somewhere else. You want to bring your own reverse proxy, knock yourself out. But out of the box, it is batteries included.
That's very cool. Could everyone give Meredith a round of applause in the chat? Really appreciate your speaking to us. That was an excellent talk.
Thank you very much.
It's been
great being here.
Thank you for staying up late to join us for this.
Yeah, absolutely. It turns out the adrenaline was carrying me right through all along, especially when the internet connection dropped 3 slides in. That has never happened to me before. I do need to give my tethered phone a slap on the back and some Gatorade, I think.
In this connected world, it's bound to happen
sooner or later, quite. Yeah. Can I get one call to action in there, which is If you want to learn more about Anvil, you can head over to anvil.works or just Google for us. My email address is on that slide if you want to email me about anything, really. And if you fancied looking more deeply into or contributing to the Sculpt Python JavaScript compiler, it's sculpt.org, SKULPT.
Well, thank you so much. And I will definitely be taking a look at that.
Awesome. Yeah. Check it out, anvil.works. Thank you very much for having me. I look forward to seeing you sometime soon.
Great. Hopefully see you at the next PyCon too.
Oh, I can't wait for it to be in person.
Yeah, me too. All right, I'm going to close out the meeting. thank you all for joining us today. And if you want to sign up for the raffle, it's not too late. I'm going to send a link out as well in the chat. My connection is a little bit laggy, so forgive the delay on the stream here. But thank you to our sponsor, JFrog. Thank you to Meredith for giving an excellent talk, and thank you to Aaron Elmquist for helping out with the stream, and of course to all of you for watching. So if you'd like to subscribe to our YouTube channel, please do so, because there's some great content coming up in the future, plus all of the excellent talks we've had that you can check out. So in the meantime, the fun doesn't have to end. We're going to head over to the ChiPy.town. That's http://chippy-town. Let me see if I can pull up the screen and just hang out for a little bit. So if you want to join and continue the conversation with Python and such, feel free to do that. So look forward to seeing you there, and I look forward to seeing you at the next event. So have a good night.